all the time to see if it works. Right, so there's your standard, no, not a standard function, we've now had a bit of a transformation. With these, we're going to need to know two things. One, to be able to sketch them and analyse features. The other one is to be able to describe them. And by describe, we talked about those transformations like we did the other day, dilations, reflections and all that stuff. You're going to be sick to death of me saying those transformations. You're going to do that for every single function we know. Dilate, translate, blah, blah, blah. But it's all the same stuff. So, if we were sketching this, the asymptotes are important. VA, HA, can't be bothered writing it. VA, vertical asymptote, shortcut. Right? Vertical asymptote, the line up and down. Bang, and the line up and down will be x equals 2. Why? Because when my fraction is 0 on the bottom line, I have a problem. Right? 3 divided by 0. I can't do that. Bang, I have a problem. So the vertical asymptote is simply, where do I have a problem? I have a problem when x equals 2. Okay? The function becomes undefined. That's my first asymptote. My horizontal asymptote, bang. Cover and read. No thinking, just cover and read. Y equals 1. Okay? That's okay. They're all good. Depends. When you disturb each other, you're all doing it at different times. So, right? Asymptotes. Label y equals 1. Pedantic things. You cannot be giving away marks. Yeah? You need to make sure you do things like label. So x equals 1. Label. So y equals 1. X equals 2. Labelled. You now need to know where they go. It's a positive hyperbola. Yeah? Now we talked the other day with all those things, how you judge. I don't care about any other sign in the world except for what's in front of x. The overall value. The overall value here is positive. So a positive hyperbola is like the basic shape we had, which is here and somewhere in here. And we'll talk about that in a second. See that? Now, I am not the best artist in the world, trust me, and I do things in a hurry. But when you do things in a hurry, don't do that. Don't be in such a hurry that you do that. What's wrong with that? Nothing being read. It doesn't approach. Do that, they go, the kid doesn't know what he's talking about. Nah, not getting it. Alright? Because you have not shown that you understand that this behaviour is asymptotic. It has to approach the asymptote. And it's easy to do. You just go, yeah, whatever, next question. So be careful. Doesn't have to be pedantic, beautiful, but it's going to look like it's approaching the two asymptotes.
Yeah, that's really intercepts.
Yeah, and we're going to do that in a second to get an idea of where we are. Right? So we want to know, because yes, there's a dilation, but I don't really want to I don't want to show that dilation if I don't have to. How do I know? Do I know if it's fat, skinny? I can't really tell. Let's do some calculations so there's no argument about how artistic I am or what my scale is. Easiest one to ever get, normally, y-intercept. So y equals x is 0, negative 3 on 2 plus 1. So we've made x 0, we found that, negative a half. So I'm down here, negative a half. Okay? So obviously asymptotic, approaching, curling, and there we go. Right, so it's that sort of shape. Find the x-intercept. Right, well, how good are we about finding our x-intercepts? Y equals 0, 3 over x minus 2 plus 1. Negative 1 is 3 over x minus 2. Yep, took the 1 over. Swap. And cross multiply, they can swap positions. X minus 2 is negative 3. X is negative 1. Graph done. Discuss. So if you got to discuss it, if you talked about dilations and stuff like that, tell me the story. What happened to this graph relative to 1 over x? Give me one. You give me one. Sorry? Translated, okay? So we've got a translation.
So, doesn't it have to become negative if you cross multiply? And 2 can't multiply.
No, all I went, yeah, but I swapped. I did it, I'll show you what I did. I did x minus 2 equals 3 over negative 1. I just picked them up and moved them. Rather than cross, I just went, you two, swap. So that's why that became negative 3 there. You want to cross multiply it, you get negative x plus 2 equals 3, you'll still come through. So you do what, yeah, you're more comfortable with. But that's what I did. I just basically picked them up, imagine they're 2 pieces, and I swapped them. So translation, 1 unit, vertically, or upwards, positive direction. All right. Someone else, another one. Any other story to add to it? You're going to force me to go to the calculator and start randomly picking on people. It's not nice. Don't be shy. Give me 2 units to the right. Translation, 2 units horizontally, whatever, to the right. Okay, no big deal. And dilation of 3. Okay. Dilation of factor 3 or by factor 3. Now, what do you say? I'm sorry, I can't hear clearly.
From the x-axis.
From the x-axis? Thank you. Is there another way of writing it? What? Yes. That's a thing that bothers people sometimes. Parallel to the y-axis or from the x-axis mean the same thing, yes.
So wasn't all that from the x-axis?
Okay, good. A dilation, if you're dilating from the x-axis, you're talking about getting your y values and making them run away. There's my x-axis, run away. So if you used to be y equals 1 and I times you by 2, you now become y equals 2. So that texture is now further away from the x-axis. Okay? So that's how they say from the x-axis means you're getting further and further away. It means your y values are getting larger.
Yeah.
Or, that dot there, parallel, imagine you're on a track, there's the y-axis and I'm going up the road parallel to the y. They both mean the same thing. Okay? But you do need to be aware of both because they can... This is the more common way of phrasing it, from the y-axis, from the x, and then if you're doing the x guy, it's from the y. So you're running away or getting closer to that axis. Yeah?
DII.
Yeah.
Good?
What DII?
So what's the DII?
Translation. This one, yeah. So just translate. So you write it, just put translation short.